There's a boundary somewhere out there, roughly 93 billion light years across, beyond which we may never see, never measure, and never truly understand. It is not a wall, not a physical edge, but something far stranger, the very limit of what light has had time to travel to reach us since the beginning of everything. And in recent years, telescopes peering toward this boundary have captured signals, galaxies, and patterns so strange that some scientists now openly wonder whether our entire understanding of the universe might be built on a flawed foundation. Objects that appear too old to exist. Regions of space unnaturally cold. Structures too large to have formed by chance. Today, we travel to the very edge of observable reality to uncover 10 discoveries that challenge everything we thought we understood about the universe, and why the deeper we look, the stranger everything becomes. For most of the 20th century, cosmologists believed they had a fairly solid understanding of how the universe began and evolved. The Big Bang Theory explained the expansion of space. The cosmic microwave background confirmed the afterglow of that initial explosion, and steady advances in telescope technology allowed scientists to peer further and further back in time, essentially looking at ancient light that has been traveling toward Earth for billions of years. Each new generation of telescopes was expected to simply confirm and refine existing models, filling in details rather than overturning fundamental assumptions. But the launch of increasingly powerful instruments, especially the James Webb Space Telescope, changed everything. Instead of quietly confirming decades of established theory, these tools began returning data that scientists struggled to explain, revealing galaxies, structures, and patterns near the edge of observable space that simply should not exist according to the standard model of cosmology. To understand why this matters so profoundly, you have to understand what looking toward the edge of the universe actually means. Because light travels at a fixed speed, looking further into space is the same as looking further back in time. When astronomers observe galaxies located near the theoretical edge of the observable universe, they're essentially looking at light that left those galaxies more than 13 billion years ago, capturing a snapshot of the universe in its earliest, most chaotic stages of formation. This means any anomaly discovered near this cosmic boundary is not simply a distant curiosity. It is direct evidence about how the universe actually began, evidence that could either confirm or completely upend everything scientists currently believe about cosmic origins. The first discovery involved a series of galaxies detected by the James Webb Space Telescope that appear far too massive and too structurally developed to have formed so soon after the Big Bang. According to standard cosmological models, galaxies require enormous amounts of time to grow to the sizes observed. Yet these early galaxies appear almost fully formed, despite existing when a universe was only a few 100 million years old. A discovery so unexpected that some astronomers have described it as one of the most significant challenges to modern cosmology in decades. The second discovery is the identification of an enormous region of unusually cold space, known as the CMB cold spot, detected within the cosmic microwave background, the faint afterglow radiation left over from the Big Bang itself. This region is significantly colder than the surrounding space, and while some scientists propose it might be caused by an enormous void largely empty of galaxies, others argue the anomaly may hint at something far stranger, potentially even evidence of another universe interacting with our own during the earliest moments of cosmic history. The third discovery involves the detection of massive, gravitationally bound structures far larger than current models predict should be possible, including enormous formations of galaxies stretched across billions of light years. These structures challenge the cosmological principle, a foundational assumption in modern physics, stating that the universe should appear roughly uniform at extremely large scales, raising uncomfortable questions about whether our fundamental understanding of cosmic structure formation may be incomplete. The fourth discovery comes from persistent disagreements between different methods used to measure the rate at which the universe is expanding, a problem known among scientists as the Hubble tension. Measurements based on the early universe consistently produce a different expansion rate than measurements based on more recent cosmic history. And despite years of increasingly precise observations, this discrepancy has not disappeared, suggesting either a flaw in current measurement techniques or a genuine gap in our understanding of how the universe actually expands over time. The fifth discovery involves unusually bright and distant quasars detected near the edge of the observable universe, powered by supermassive black holes that appear to have grown to billions of solar masses far earlier than existing models believe should be possible. Explaining how these black holes achieved such enormous size so quickly after the Big Bang remains one of the most actively debated puzzles in modern astrophysics. The sixth discovery comes from faint, mysterious ripples detected within the cosmic microwave background that some researchers believe could represent evidence of events occurring before the Big Bang itself, an idea that directly challenges the long-held assumption that time and space began at a single, definitive starting point. While highly controversial, these findings have opened serious scientific discussion about whether our universe may have emerged from some kind of prior cosmic state. The seventh discovery involves unexpected variations detected in the strength of fundamental physical constants when measured across vast cosmic distances, suggesting that forces we assume to be perfectly consistent throughout the universe, such as the speed of light or the strength of electromagnetism, might vary subtly depending on location or cosmic era, a possibility that, if confirmed, would require significant revisions to nearly every equation used throughout modern physics. The eighth discovery comes from the identification of unusually empty regions of space called cosmic voids, some stretching across hundreds of millions of light years with far fewer galaxies than expected, alongside unexpectedly dense clusters found nearby. This uneven distribution challenges simplified models of cosmic structure formation, suggesting the underlying processes shaping the large-scale universe remain more complex and less understood than previously assumed. The ninth discovery involves gravitational lensing observations near the edge of observable space, revealing mass distributions that do not fully align with visible matter, adding further evidence to the mystery of dark matter, an invisible substance believed to make up roughly 85% of all matter in the universe, yet never directly detected despite decades of dedicated search efforts using increasingly sensitive instruments. The 10th and perhaps most unsettling discovery involves the theoretical possibility that what we call the edge of the observable universe may not represent any kind of true physical boundary at all, but simply the limit of what light has had time to reach us since the beginning of cosmic history. This means the actual universe could extend far beyond what we will ever be capable of observing, potentially containing regions, structures, or even entirely different physical laws forever beyond humanity's reach, a boundary defined not by space itself, but by the simple limitation of time. These discoveries carry consequences that reach into the very foundations of physics and cosmology. If galaxies really did form faster than current models allow, scientists may need to fundamentally revise their understanding of how matter clumped together in the early universe. If the disagreement over the universe's expansion rate cannot be resolved through improved measurement techniques, it could indicate the existence of entirely new physics not yet incorporated into the standard cosmological model. Each of these anomalies represents not simply an unanswered question, but a potential crack in the framework scientists have relied upon for decades to explain the origin and evolution of everything that exists. The broader impact of these findings extends into how future space missions and telescopes are designed and funded. Discoveries near the edge of the observable universe have directly influenced decisions to develop even more powerful instruments capable of peering further back in time with greater clarity. As scientists race to determine whether these anomalies represent genuine flaws in existing theory or simply the limitations of current observational technology. Billions of dollars in research funding now depend on resolving these fundamental questions about how the universe truly began and evolved. Not every scientist agrees on how seriously to interpret these anomalies. Some researchers argue that apparent contradictions will likely resolve themselves as measurement techniques improve and observational errors are corrected, pointing to historical examples where seemingly impossible data eventually fit comfortably within existing theoretical frameworks. Others believe these anomalies represent genuine evidence that something fundamental about our understanding of cosmic origins remains incomplete, arguing that dismissing these discoveries as simple measurement errors risks overlooking one of the most significant scientific revolutions in generations. This ongoing disagreement reflects the genuine uncertainty still surrounding humanity's understanding of how the universe truly began. Perhaps the most profound realization from exploring the edge of observable reality is recognizing just how much remains unknown about the very fabric of existence itself. Every galaxy discovered near this cosmic boundary, every unexplained ripple detected within ancient radiation, every unexpected structure stretching across billions of light years, serves as a humbling reminder that despite generations of scientific progress, humanity has only begun to understand the true scale and complexity of a universe we call home. What lies beyond the edge of what we can observe, and how many more discoveries are waiting there to reshape everything we currently believe. If exploring these mysteries at the edge of the universe left you questioning everything you thought you knew about reality, consider giving this video a like. It genuinely helps more curious minds discover stories like this one. Let us know in the comments which discovery surprised you the most, or which cosmic mystery you would like us to explore next. And if you want to keep uncovering the strangest, most mind-bending secrets hidden across the universe, subscribe to the channel, because the biggest revelations about our existence may still be waiting to be found.